The 68, 95, 99.7 rule refers to a standard normal curve, something like this, in which the high point of the curve is always where the mean lies. 68% approximately of the area under this curve. Now the area under the curve is equal to 1, meaning actually 100%. So it's talking about the percentage of area under this curve. 68% of the data is going to fall between the points that are 1 standard deviation above and 1 standard deviation below the mean. Now, if 68% is in between these, then because it's symmetrical, half of that, or 34%, is going to lie on each side of this. Let me do this in a different color. So 34% lies here, and 34% falls here. Now, if we go 1 more standard deviation up and down, so this would be our average plus 2 standard deviations. This is going to be the average minus 2 standard deviations. The difference between the first section here and from here to here, you have 95% of your data. Well, we already have 68% of that accounted for. 95 minus 68 is going to be 27. So these 2 spots add another 27%. Now, if the total of this is 27%, then half of the 27, 13.5%, lies in each of these places. So this spot has 13.5%, as does this. After we get past the second deviation, and we're into the area where we're going to find between the second and third deviation, which is going to be right in here. Let me try another color. This part in here, when we get 1 more standard deviation out, so this would be our average plus 3 standard deviations. This is our average minus 3 standard deviations. Adding these 2 spots, and I shouldn't even go all the way out. So just these 2 spots, it goes from 95% from here to here to 97.7% from here to here. And the reason it's such a small part left is because these lines are supposed to be really, really low. So what we've added here, we've accounted before for 95%, adding the third standard deviation brings it out an additional 4.7%, half of which is going to fall on both sides. So now we've got 2.35% has been added on here and here. And then this accounts for all but 0.3% of the area under the curve. So on the outside of the third standard deviations is an additional 0.3%, which is going to be split evenly between the two ends. Half of 0.3 is 0.15. So this last little tiny bit here would only have 0.15%. Now, for this particular problem, this will be true every single time. As a matter of fact, I would suggest you draw this out and keep it in your notes handy, because that will let you answer all the problems that are like this. So now they're saying the mean is 17, the standard deviation is 3. So that means this is 17. If the standard deviation is 3, then 17 plus 3, one standard deviation out would be 20, plus another standard deviation of 3 would put this at 23, and a third standard deviation would be at 26. Going the other way, we're subtracting standard deviations, so subtracting 3. So 17 minus 3 is 14. 14 minus 3 would be 11, and 11 minus 3 is going to be 8. Now we can answer any question. They want to know the percentage of values that lie below 23. Okay, here's the 23. It might be easier, instead of adding this and this and this and this and this and this, it might be easier to just add these two and then subtract that from 1. So why don't we do that? If I take the two parts that are above that, that would be 2.35% and 0.15%, which is going to be 2.5%. So this part up here contains 2.5%, which means all the rest of it, 100% minus 2.5%, don't need that one, do I? Is going to be 97.5%. So the answer to this, 97.5. Excellent.